look at another example. Let's find the value of h prime at -1 for this function. Okay, so h prime at x. Let's do the derivative of the first thing, which we get 15x squared plus 14x. Okay, times the second thing as it is, plus the first thing as it is, which is a lot of copying here, multiplied by the derivative of the second term, which is 4x plus 1. Now, you can expand all this, but it's a little tedious and you may make a mistake. I'm just going to straight in substitute the -1. So -1 squared is just 1. We have 15 and then minus 14. 1 squared is 1. 2 minus 1 plus 6. Okay, for this one we get -5 plus 7 plus 3. And for the last one we get -4 plus 1. So 15 minus 14 is 1. 6, 7, 8. 8 minus 1 is just 7. Plus, this is 2, 3, 4, 5. And the derivative of 4x plus 1, or sorry, just -4 plus 1 is -3. So we get 7 minus 15, I get -8. So therefore, h prime at -1 equals -8. Now, what if we run into an expression that doesn't just have 2 terms multiplied by each other, it actually has 3 terms? What are we going to do? Okay, so let's go actually through the steps of finding out how to make the formula. So we're going to start with grouping f at x, g at x, and then having h at x as the second term. So this is the first term, this is the second term. Okay, so to find the derivative, we need to take the derivative, so I'll just put f at x, g at x prime, derivative of the first thing times the second thing, plus the first thing as it is, times the derivative of the second thing, so h prime at x. So let's actually think about what the derivative of f at x, g at x is. Well, we know that if it's f prime at x, g at x, plus f at x, g prime at x. Okay, that's what the derivative of that is. And then we'll put h at x. And then this is just normal, so we can do f at x, g at x, and then we can just write h prime at x. Now all we do is expand this h at x into the bracket. Okay, so we have f prime at x, g at x, h at x, plus f at x, g prime at x, h at x. And then finally f at x, g at x, and then h prime at x. So if you look at this pattern, you multiply all three of them by each other, but in the first term, you differentiate the first expression. In the second term, you differentiate the second, so f, g, and then this one is h prime. So that's going to be our formula for differentiating anything greater than 3 products, like 3 things multiplied by each other. Now we're going to look at the power of a function rule for positive integers. Okay, so we already saw the power rule, but when we actually have an equation such as this with a power, we actually have to use something called the chain rule. So what we're going to do is we're going to take, say we have g at x to the n. We're going to bring the n down, write g at x as it is, and then do the n minus 1. That's the normal thing that we do. So up until here, it's normal. What we're going to then do is multiply that by the derivative of the actual expression. So up until now, all we've seen is something like x to the 6th, and then we bring down the 6th. But now it's an actual expression to the 6th. So let's bring down the 6 as normal. Let's copy this out as normal. Let's subtract 1. So to the 5 is normal. The extra part here is the chain rule. So now we have to take the derivative of what's in the middle. So we get 2x plus 3. And that's it. You don't have to expand this. It's really ugly. It's to the exponent 5. Okay? Neither of these are like terms, but that's all we do.